Hey, this is Mr. Elmhorst with the sixth grade math help video for the identifying independent dependent variables homework. We're going to look at the graphs and take a look at the ordered pairs from the graph and also identify the independent and dependent variables. So the first thing we can do is we're going to label the independent variable. X is your input, Y is your output, and this is going to be your independent variable, and then this will be your dependent variable. So we need to put time in first in order to get the tree to grow and give us height. So, okay, so taking a look at this, so the independent variable is going to be time, and the dependent variable is going to be height. So looking at the x and the y for this graph, we're going to start with the x over here and find the solid circles on the graph and then make a table. So the first one is going to be 0. And when x is 0, we also look at this one, y is also 0. And then when x is 1, we go up and out, and it looks like y is 5. 1, 5. When x is 2, y is 10. So just looking at this, this is not an adding rule, 0, 0. Nothing was added, and 1, 5, 2, 10. This looks like it is a multiplying or multiplicative rule. So then over here, 0, 1, 2, 0, 1, 2, 3, 4 for the input variables. And then we have 0, 5, 10, 5, 10, 15, 20 for the output variables. So you can work ahead at any time. We just went through one example with graph 1. Go to graph 2. You got the brother's age is your independent variable. And then the dependent variable is going to be the sister's age. Then looking at the first point here, coming down to x, when x is 0, then we come over here, and it looks like it's maybe 2.5, 2.5 years older. And then when x is 1, that looks like that is about 3.5 for y. And then 2, when x is 2, so when the brother is 2 years old, it looks like the sister is older. And that looks like it's 4.5. So whatever the x variable is, whatever the brother's age is, it looks like it's adding 2.5 years to get the sister's age. So the input values are going to, which is the x, is going to be 0, 1, 2. And then the output values, which are going to be the y values, 1, 2.5, 3.5, 4.5. We're going to do one more example here. So it's tickets sold. So the number of tickets is your input, and money collected is your output. Starting with the first point, x is 1. When x is 1, it looks like y is 2. 2, 4, 2, 4, 3, 6. So it looks like the tickets are $2 each. So each one of the input variables, each ticket is multiplied by 2 to get the dollars. So we have 1, 2, 3, 4 for the input values. 1, 2, 3, 4. And then the output values are going to be 2, 4, 6, 8. Okay, finish the last one on the bottom, and then we're going to move on to the next part. Okay, now we're going to look at graph 5. So the independent variable looks like it is centimeters, and then the dependent variable is kilometers. You got centimeters and kilometers. And if we look at the start here, 0, 0, and it looks like it's 1, maybe 8, and then 2, 16. So when x is 0, y is 0, it's here in the corner in the origin. When x is 1, y is 8, x is 2, y is 16. So it looks like there's nothing added, 0 to 0, there's no adding, so we have a multiplicative rule, and it looks like it is multiplying times 8. So 8 times x equals the output of y. So it looks like we have loads, the number of loads, and then the total cost. So looking at the first x right here, the second, the third, and the fourth. So it looks like it's 0, 1, 2, 3, 0, 1, 2, 3, and then we look at the output, 2, 3, 4, 2, 3, 4. 0 to 2, the only way to do that is to add. Multiplying would not work. 0 times anything would be 0. So we have an additive relationship, and then it's x plus 2 equals y. So it looks like we have tickets and cost. Tickets and cost. And 1, 9, 2, 18, 3, 27. And then if we went all the way down, this would be 0, 0. 1, 9, 2, 18. 0, 0 cannot be added to anything, so it's multiplicative, and it looks like it's multiplying by 9. So we have 9 times whatever the x is, the input, will give you the output of y.